Hi, today I'm going to talk about something a little different than development of my game that I normally talk about here on this channel. And I'm going to talk about a machine learning approach that I've implemented to play the game of Go. And this algorithm or approach that I've implemented is very similar to the AlphaGo Zero approach by DeepMind, and they've described it in multiple papers and in more detail elsewhere, so I'm just going to briefly review it here and spend the bulk of this video playing the network that I've trained. So basically so I also want to say that the connection to the game that I'm developing here on this channel is not really existent, but I would say on the longer term, I hope to have some type of AI like this trained in somewhat of an organic reinforcement learning nature, or at least a little more so than this, to have a challenging adversary for you to play in the game. But as of right now, this is just a separate topic that I've worked on as just out of interest for the most part. So anyway, the approach that I've implemented is to have this neural network play against itself and to train itself to make predictions about how the games that it has played itself, how they will come out. So for instance, if the network is playing against itself, it will make a series of moves and put the game in a series of consecutive states. And then in each of these states, the network and the algorithm branch over a tree search of multiple possible states that could be reached from the current state. So it makes many different types of moves and then plays out the full game and sees, in a sense, how the game results and who wins. And with these, the network in a way guides the tree search to go to promising directions in the game that are likely to win. And it's kind of a circular thing. So it's you train it in this way, and you train it to make to predict the outcomes of these games. And over time, it eventually becomes quite good at predicting how the game will go. And consequently, it becomes quite good at playing the game of Go. So I've also written about this in the past. I wrote about a year ago a Medium post that I've also reposted on my website, where I just describe what I've done, which is, again, similar to the papers by DeepMind, but I've also released my source code that I try to document in these Medium posts. And I've written also an updated post where I describe some changes that I've made that have resulted in improved gameplay from the model. There were some problems that, if you're interested, you can read about in the post that I wrote. Anyway, let me move on to playing the game, and you can see for yourself how good it is, or maybe how bad I am at playing Go. But here we go. Let's play a few matches. So I'm going to start the first few games where I'm going to let the network play as black. That is, it gets to play first, and then I'll play second. It plays fairly aggressively, as you might see. It's always a balance, because I don't know, if I play too defensively, I quickly get put in a corner, but if I start to be aggressive, I feel like I just start making mistakes. So I don't know I haven't developed a good strategy for this. See, I've just lost all this. If I go there, you know, let's try to take this one at least. That was stupid. I shouldn't have done that. Yeah, that's pretty much this game. It looks like I lost by about 8 points here. So let's try again. Oh, this is horrible. It's not much hope now. I can't believe it. Oh. Yeah, I think this one, there's no chance for me to come back. Looks like it won by 3. So the way that this is scoring it is that it doesn't, you know, if we were to play this out, I think it would basically get all of this territory going below my mouse. But the way that I score the game is that because I have this stuff here, it doesn't actually count that it owns all of this. So I guess what I'm saying is it really won by a much larger margin than is suggested by this. Let's play one more with it playing first, and then I'll switch over to have me play first. I have a little. Oh, what happened here? Oh, this is really bizarre. Hmm. Okay, well, it looks like I won that one then. That's actually interesting because I hadn't won against it before when I played as white. I guess it had some type of stroke or something. It was really screwing around those first few moves. Um, let me play a game um, where I play first. Change which. So I'm just changing the variable in the script so that it sets me as playing first. Yeah, that one is just lost. I don't know how I managed to lose this one. I'm able to beat it sometimes with white. I'm surprised. I mean as when it plays as white, I guess it's not so surprising that I lost. All right, let's try another. My performance is embarrassing today. Just losing things needlessly. Even lost that center part. I can't believe it. Yeah, okay, it looks like I've won this one. Won that one by a score of 3. Let's do one last one with this setup, and then I'll do some self-play ones where the network plays itself. Yeah, I'm not seeing how I'm gonna come back from this one. Yeah, whatever. Lost that one. So now instead of making moves as I choose them, I'm gonna, let me see here. I'm gonna make moves based on where the network has the highest probability of going, so it's as if it's playing itself. Due to some technical reasons in the way that I set up the training script, I have to do it with a different version of the model where I was actually doing some auxiliary score functions. I just hadn't updated the GUI script to show the probabilities for the, or rather I updated it and then just made it incompatible with what I had previously for the display script. So I'm going to show you something on a technically different model, but it is similar in performance from what I've seen, maybe a little bit worse. Okay, so I right click. This is where the network would move if it were going next, so I'll just choose the max. So it looked like white won this one. Yeah. Let me do another. Yeah, so it looks like black won that one. Let me go back and play the network, the technically slightly better one, again as the second player. I'm a little disturbed by that last game I played with it, where it was going first. See what it does again, if that was just some weird fluke or not. Should have saw that coming, and I was just gonna lose that. Really turns the game around. Not in a good way for me. Should have saw that. That was a waste. Now I lose that one. I guess that's probably the game. Yeah, so I looks like I lost by 5 there. All right. Anyhow, that's all I'm gonna play for today. Thanks for watching. If you find it interesting, like I said, there's plenty more details online in both the paper and the articles I've written on the code. If you're sufficiently inclined, you could download it, set up TensorFlow, and play it yourself, or train your own version of it. All right. Well, thank you.